Alright, so this video is about allotropes, and specifically allotropes of carbon. So first, what I should do is I should tell you what an allotrope is, and here's my definition. And here it is. An allotrope is when a pure element's atoms, bond together in multiple ways. So just as an example of an allotrope, right here, tin has a couple different main allotropes. There's regular tin. If you've ever seen just plain old pure tin before, that's what you have at room temperature. But if you get it really, really cold, tin turns into another form that's actually less dense. So even though they're both pure tin, they have two different ways the atoms get together. So that's what an allotrope is. So, like I said, this video is about carbon, and I think I've told you before that carbon is pretty amazing because each carbon atom can get together with 4 other atoms, and that means it has plenty of allotropes. It has plenty of different forms. So if you go out and Google carbon allotropes and then click images, you're going to see something like this. And so just my eye is caught by this one, diamond. Diamond is one allotrope of carbon. Here's one called graphite. That's what we use in your pencils. In the old days, they actually used lead, but no longer. It's been a long time since we've used lead. And you can take carbon and you can put it together in these long tubes called nanotubes. That's relatively new technology. Let's see here. Let's just go through this. So A is diamond. So if you could see the carbons in a diamond atom, or a diamond, you'd see carbon atoms bonded together like this. In a pencil, graphite, right here, you'd see all these flat layers of carbon. And that's why when you slide a pencil across your paper, it's depositing these little sheets of carbon. C is called Lonsdaleite. That's a mineral. It looks kind of like diamond, but it looks a little bit wonky. Here's D, E, and F. If they get together and make a ball, they're called fullerenes, after this dead guy named Buckminster Fuller. My history here is not very good. And then G, amorphous carbon. That's when it gets together in this wacky random pattern. And then there's the carbon nanotubes that I talked about already. So those are the different allotropes of carbon. And so you can look forward to seeing one question about that on the carbon quiz. And there's your short video on carbon allotropes.